Programming language. Introduction. A programming language is a set of symbols, grammars, and rules with the help of which one is able to translate algorithms to programs that will be executed by the computer. The programmer communicates with the machine using programming languages. There are many different classifications of programming languages, and these programming languages differ in their closeness to the machine and in the way they are structured. Most of the programs have a highly structured set of rules. The primary classifications of programming languages are machine languages, assembly languages, high-level languages. Machine-level language. Machine language is a collection of binary digits or bits that the computer reads and interprets. Machine language is the only language a computer is capable of understanding. Machine-level language is a language that supports the machine side of the programming or does not provide human side of the programming. It consists of binary zeros and ones. A machine-level language is the lowest form of computer language. Each instruction in a program is represented by a numeric code, and numerical addresses are used throughout the program to refer to memory locations in the computer's memory. All bookkeeping aspects of the program are the sole responsibility of the machine language programmer. Finally, all diagnostics and programming aids must be supplied by the programmer. Also included as machine-level programs are programs written in microcode, that is, microprograms. Microcode allows for the expression of some of the more powerful machine-level instructions in terms of a set of basic machine instructions. Each computer has only one programming language which does not need a translating program, the machine language. Machine language programs, the first-generation programs, are written at the most basic level of computer operation. Because their instructions are directed at this basic level of operation, machine language and assembler language are collectively called low-level language. In machine language, instructions are coded as a series of ones and zeros. The machine language programs are cumbersome and difficult to write. The machine language is native to that machine and understood directly by the machine. The machine language generally has two parts: opcode, operand. The opcode of machine language tells what function to perform to the computer. The operand gives the data on which the operation has to be performed or the location where the data can be found. Advantages. Machine-level instructions are directly executable. Machine-level language makes most efficient use of computer system resources like storage and register. Machine language instruction can be used to manipulate individual bits. As the machine inherently understands machine instruction, machine languages are very fast. Disadvantages. Difficult to program. Programming in machine language is the most difficult kind of programming. Instruction should be encoded as a sequence of incomprehensible zeros and ones, which is very difficult. Error-prone. In machine language, the programmer has to look into all the activities like memory management, instruction cycle, etc., which diverts his attention from the actual logic of the program. This frequency leads to error. Machine dependent. Every computer is different from one another in its architecture. Hence, instructions of one machine will be different from the other. As machine-level language are device-dependent, the programs are not portable from one computer to another. Programming in machine language usually results in poor programmer productivity. Programs in machine language are more error-prone and difficult to debug. Computer storage location must be addressed directly, not symbolically. Machine language requires a high level of programming skill, which increases programmer training costs. Assembly-level language. A set of instructions for an assembly language is essentially one-to-one with those of machine language. Like machine language, assembly language is unique to a computer. The big difference is that instead of a cumbersome series of ones and zeros, assembly languages use easily recognizable symbols called mnemonics to represent instructions. As said before, machine language and assembly language are low-level languages and are dependent on particular machine architecture. They are more close to the machine rather than the programmer. The only difference between the assembly language and machine language is that assembly language is relatively easier to use than machine language. In a pure assembly language, each statement produces exactly one machine instruction, one-to-one correspondence between machine instructions and statements in assembly language. So, an online assembly language will produce an N-word machine language program. Assembly language which uses mnemonic codes is easier than machine language using binary or hexadecimal codes. It is easier to remember ADD, SUB, MUL or DIV than their corresponding numerical values in machine language. Assembly language uses symbolic names for memory locations while machine language needs numerical values. The assembly language can directly test if there is an overflow bit while a higher level language cannot. An assembly language can only run on one family of machines. Each machine has its own assembly language, while a higher level language can run on many machines. Advantages: assembly language is easier to use than machine language. An assembler is useful for detecting programming errors. Programmers do not have the absolute address of data items. Assembly language encourage modular programming. Disadvantages: assembly language programs are not directly executable. Assembly language are machine dependent and therefore not portable from one machine to another. Programming in assembly language requires a higher level of programming skill. High-level language. High-level language is a language that supports the human and the application side of programming. Typical features: ability to logic structuring of the algorithm, cross-platform independence. A language is a machine-independent way to specify the sequence of operations necessary to accomplish a task. A language can be designed to be expressed in a concise way, a common sequence of operations. A line in a high-level language can execute powerful operations and correspond to tens or hundreds of instructions at the machine level. Although many programmers prefer assembly language because it works more efficiently, the power and flexibility of the new generation languages have put them beyond low-level languages in terms of both human and computer efficiency. Consequently, more programming is now done in high-level languages. Examples of high-level languages are BASIC, VB, C, C++, Java, Perl, etc. High-level languages are more like English statements which are easy to understand and to use. High-level languages are more close to the programmer and ease the task of programming. High-level languages provide a richer set of instructions and support, making the programmer's life even easier. Yet, before a high-level program can be executed on a given CPU, it must be translated back to the machine code. A programming language such as C, Fortran or Pascal that enables a programmer to write programs that is more or less independent of a particular type of computer. Such languages are considered high-level because they are closer to human languages and further from machine languages. In contrast, assembly languages are considered low-level because they are very close to machine languages. Features of high-level languages. High-level languages are easily understandable. The programs that are developed in high-level language are portable. In case of high-level languages, debugging of the code is easy and the program written is not machine-dependent. Advantages of high-level languages include easier to program. The programmer can concentrate on the logic of the program rather than on the register, ports, and memory storage. Machine independent. Provided some other machine has the same compiler and libraries, the program can be ported across various platforms. Easy maintenance. A program in a high-level language is easier to maintain than assembly language because it is easier to code and locate bugs in high-level languages. Easy to learn. The learning curve for high-level languages is relatively smooth than low-level languages. Other than this, high-level languages are more flexible and can be easily documented.